We have discussed last time that increasing the concentration of the reactants generally increases the rate of the reaction. Now, there are actually different patterns or different order or trends on this relationship between the change in the concentration and then the change on the speed of the reaction. Let us consider the following experimental data. So here we have A and B. A and B are the reactants here. So first, we are going to observe the impact of changing the concentration of the reactants to the rate of the reaction. Since here we have two reactants, so we are going to observe them individually. So in this case, I'm going to observe first the A and then its impact on the rate of the reaction. So in this case, the other reactant must be held in constant. Okay, so bakit need dapat constant sa B? Okay, let's say nag-change po sa B for example. So from 1 molar to 2 molar. So in this case, nag-change si A from 2 to 4 molar, the same thing kay B. Then obviously, this will affect the rate of the reaction. So merong change also on the rate of the reaction. So in this case, merong change, pero it's hard to know whether this change is caused by A or B, because as you see here, both A and B are also changing. So it's really important to observe the impact of each reactants individually. So again, on this case, I'm going to first observe the impact of A to the rate of the reaction. While observing this one, B must be controlled so it won't affect the rate of the reaction. So again, on this case, B must behave for now. So our change on rate is only caused by change on A. So here, as you see here, our B is kept in constant. It's behaved for now. It's still 1 molar, then 1 molar on this experiment 1, then experiment 2. Okay, so let's see the relationship between the change in the concentration of A and then the change on the rate of the reaction. So in this case, we have increased our concentration of A from 2 to 4 molar. It's an increase by a factor of 2, so we double this one. Let's say the impact of this one to the rate of the reaction. So in this case, from 0.25 molar to 0.50 molar, the rate increased by a factor of 2. So again, this change in rate is caused by the change in the concentration of A. It's not caused by B because obviously B is behaving. It's not doing anything here. Now let's see the order of the reaction. So here the order is equal to the power to which the concentration of the reactant is raised. So in this case, our concentration increased by a factor of 2. It will be raised to some power. Again, this power is the order of the reaction. It's equal to the change on rate. On this case, the rate changed by a factor of 2. So in this case, if 2 to the power of x is 2, then what could be x here? Obviously, x is equal to 1 because 2 to the power of 1, that's equal to 2. So this one is a first order reaction. So here the power is equal to 1. Let's see how this works on the next change on the concentration of A. Let's say from 2 molar, it become 6 molar. So again, B must behave first, so it won't affect the rate of the reaction. So in this case, 6 molar, what do you think will be the rate on this case? So let's see first the change on the concentration of the concentration of A. So here, the concentration of A increased from 2 to 6. So in this case, increased by a factor of 3. So in this case, this one is a first order reaction. Therefore, the power here is equal to 1. So 3 to the power of 1 is equal to 3. So again, this 3, that's the change on the rate of the reaction. So from 0.25, multiply this one by the 3. Again, this is the impact on the change on the rate. So from 0.25 times 3, that's equal to 0.75 molar per second. So that's the rate when the concentration of A is 6 molar. Let's continue this one and let's see the effect of the change in the concentration of A to the rate of the reaction. So here, let's say from 2 molar is naging 8 molar. So from 6 to 8 molar. Again, B must behave first. So in this case, from 2 to 8, that's a factor of 4, right? From 2 molar to 8 molar. So 4, again, this is a first order reaction. It's equal to 4. Again, this 4, that's the change on the rate of the reaction. So from 0.25, the same impact times 4 on the rate is equal to 1.00 molar per second. So this is the pattern for first order reaction. Let's observe another set of experimental data. On this case, we are going to, okay, so on this case again, the power is equal to 1. That's the rate of the reaction in respect to A. Let's go now to B. So for B now, we are focusing on B, then effect sa rate of the reaction. So in this case na po, the other reactant must behave, or it must be held in constant. So again here, A is constant, B is changing. The change in B will impact the rate of the reaction. So let's observe this one. So from 2 molar to 4 molar, what happened to the change in B? That's a change by a factor of 2, right? That's from 2 to 4. Let's see the impact of this to the rate of the reaction. That's from 0.25 to 1 molar. That's equal to 4. So let's determine the order of the reaction. So here again, the change in the concentration of B is 2. It will be raised to some power x. That's equal to the change in rate, which is equal to 4. So in this case, if 2 to the power of x is 4, what is x? X is obviously equal to 2. So this one is a second order reaction. Okay, so let's again try to understand this one. On this case, RB increased by 2 impacts a rate that's times 4. So that's the squared. That's the squared of the change on the concentration of B. So in this case, that is times 4. That's different from the first order reaction. So again, this is the first order reaction. Here, we have multiplied the concentration by 2. The same impact on the rate of the reaction is still also times 2. So again, first order and second order reactions have different patterns or impact on the rate of the reaction. Let's continue this one. Let's say from 2 molar naging 6 molar. Again, A must still behave for now because we don't want it to affect the rate, because we only want to know the impact of B to the rate of the reaction. So in this case, from 2 to 6 molar, increased by a factor of 3, right? So in this case, 3, it will be raised to the power, its second power. So here, it's 2. So 3 squared, that's equal to 9. So this 9 will be the change on the rate of the reaction. So in this case again, times 3, the squared of 3, that's equal to 9. So if we solve this one, 0.25 times 9, let us use the calculator here. So that's 0.25 times 9, sorry, 0.25 times 9, that's equal to 2.25. So here the rate will be 2.25 molar per second. So again, this is the pattern for second order reaction. Let's proceed with another reaction. So here C and D are the reactants. So first we are going to focus first on C. So since we are focusing on C, D must be held in control. So in this case, D is constant on this case, and only C is changing. So in this case, from 2 to 4, it increased by a factor of 2. Okay, that's by a factor of 2 raised to some power. Let's say the impact of this on the rate of the reaction. So that's from 0.25 to 2 molar per second. That's equal to 8. So an increase by a factor of 8. So in this case, the change in rate is by a factor of 8. So in this case, 2 to the power of x is 8. Then what do you think is x on this case? On this case, it's equal to 3 because, of course, 2 times 2 times 2, that's equal to 8 on this case. So this one is a third order reaction. So let's observe this one from 2 molar to 6 molar. Again, D must behave for now. So from 2 to 6 molar, it is increased by a factor of 3. So 3, again, this one is a third order reaction. So the power is 3. That's equal to 27, right? That's 3 times 3, 9 times 3, 27. So here, the impact on the rate, that's cube of the change on the concentration of C. So cube of 3, that's equal to 27. So from 0.25, let's solve that one. 0.25 times 7 is equal to 1.75. So on this case, the rate, wait, let me check. 0.25 times 27 is equal to 6.75. So the rate here is 6.75 molar per second. So this is the pattern for third order reactions. Let's observe the last one. So here I'm going to focus on D. So here C must be constant. As you see here, it's constant. It remains 1 molar throughout the experiment. So the change in D will affect the change in rate of the reaction. So from 2 to 4, it increased by a factor of 2 molar or 2. And then here, as you see here, the rate is the same. So it's just the same, so that's equal to 1, right? So 0.25 times 1 is equal to 0.25. So in this case, 2 to what power is equal to 1? So x here is equal to 0 because 2 to the power of 0, that's equal to 1. So this one is a zero order reaction. So as you see here, it remains the same. So we are changing the concentration, but okay, on this case, that's times 3. Okay, 3 to the power of 0 is equal to 1. So in this case, it will remain the same. From 0.25 times 1, it's still 0.25 molar per second. So in zero order reactions, as you see here, changing the concentration of D does not affect the rate of the reaction. It's still the same whether we have doubled or tripled the concentration of D. So these are the different orders of reaction.